Most probably, good afternoon, everybody. I'm Krishna Kumar from Bharati Dasan University. So I'm from basically a biotechnologist. So I want to know how many are bioinformaticians here studying bioinformatics. Okay. Mostly 50-50. Okay, my part is 50 people are there for my representation. Thank you. So yeah, before that there was a problem with the script file. They were thinking, and I am not used to script. I don't know what is script previously, but now I am very good with Veka. How to run Veka and what are the parameters. So I can understand this, that I don't know Java class path. In Veka there is classifiers. In that classifiers there is a classifier branch called meta. In that meta we will be setting cost sensitive classifier, and matrix is that 1, 2, 3, 4 what you studied in maths. It's nothing great. 0.0, 10, 1 and 0. It's very simple. So again, AD162 is the file which you put, the query file you put, and X5, I don't know, that's something. So I can right now identify more than 50% of it. So hope bioinformaticians, it won't take time. I think it may be few days. So it won't be a big problem. I hope so, sir. So thank you very much. So right now I'm here to present a small case study done by our OSDD group. So as I'm a biotechnologist, I want to say layman example. So what we have, what we need to do, what we want. So we have already people for Mycobacterium tuberculosis have screened so many things, just like as such, and they have high throughput screening data, lakhs and lakhs of compounds they are screening, they are having the results. So who will take that results into account? How it can be accountable? Another thing is that this is the resource we have. We have a lot of chemical compounds tested, and we have a lot of answers for it, whether it is active or not. So that's high throughput screening. You could read about it later. So we need a drug for Mycobacterium tuberculosis. So what is lacking behind? It's a sieve. So basically you think how to extract a gold from a soil. So you should need a sieve. So if you put it that the sand particle should be there on top, the gold should here. So see the magnitude, composition of the magnitude of the gold in the soil. It's like that the compound of the drug, what we are searching in a database. So this is the basic concept. What I feel. So it depends on N people. How I infer. So this sieve, what is this sieve? So we are working to make that sieve. In a sieve, it's like a threads, network of threads. It's not one thread, it's network binded like that. So each network will be a filter to make that compound which is very lead, which will be very much active against Mycobacterium tuberculosis and also safe for us. So these two parameters we are thinking of it, will be keeping two things. So it should be safe for us and also should be active against Mycobacterium tuberculosis. So these two things we keep in mind, and we are developing a sieve. In your terms, it's called a model. Lot of models, putting software. You can say many things. Filters. And I don't know many terms in bioinformatics. So yeah, this is what Chemiformatics we need to do. So as far as that thing, they have given 5 AIDs. We don't know at that time of starting. They given a biosay paper, model paper, that how Veka is working. They given us, and we all were training all the 40, not 40. Very few people were training first, then others joined. So we are interacting with everybody. What's the doubt? Usually I ask query to Vinita, Anurag. Many people like in my groups we used to have all-round discussions, and late night also, as Sir said yesterday. So we'll be finding solutions how to go to the next step. As a biotechnology students, I have some hurdles in working with bioinformatics tools. So they used to clear. So to get trained in using different classifiers in Veka and analyzing the results, a case study has been given, 899. So from that case study, actually the case study was related to It's AD899 is, I think I left a slide, I'm sorry. I'll tell that AD899 is a high throughput screening data. So it has around 9 lakh compounds screened against human COP450 protein, subfamily C domain. It was, many compounds has been tested on it, whether it affects our COP450 or not, and they have been, the results have been there that it is active, that out of 9,000 molecules, something will be active, something will be inactive. So all the thing will be there with AIDs. So why here COP450 comes? It's an important factor. And it's in Mycobacterium tuberculosis, COP is also an impacting factor. That's why COP450, not coming to human, but when we see it in Mycobacterium, it's P450 monooxygenases, it's a xenobiotic degradation enzyme. It detoxifies the toxic compounds in basic. So it generally interacts with, so MTB genome sequence, it's called as plethora of 450s, P450s. So why? It's very dense with compared to eukaryotic genomes. So right now, most effective azoles are extremely tight binding. Azole drugs has been developed primarily for TB, but after they are analyzing its activity on computational things, they found that they are mostly interacting with P450s subfamily. So that right now the medicines we are having, they are pretending to tell it's working with COP450. So thus the analysis of reveal it's irreversible. On analyzing that, they came to conclusions that it's irreversibly inactivated and structurally disrupted species.